Alright, today what we're looking at, as it says here, vector components. And in particular, what we're looking at is what we call the I and J form. So here we've got two dimensions is what we're working in. So we're working what we call I and J. And so, as we're saying here, the definitions, I is the vector of length 1 unit in the x direction. All right, so points to, if we're looking at what we would normally think of as our Cartesian plane, where we've got x-axis and y-axis, this relates to that. So the I vector is length 1 unit in the x direction, and the j vector 1 unit in the y direction. So if I go and have a look here, and so in this particular diagram, the vector AB, that's the one that goes here from A to B, you could write as 3i plus 4j. All right, so because here from A to B, we go from 2 to 5 in the x direction, which is 3 in the positive x direction, so 3i, and 4j, we go from 3 to 7 in the y direction, the j direction, so 4j. And so the components, the two I and j vectors that comprise the vector AB, the components of AB are 3i and 4j. All right, so we're using the I and j forms. All right, so here we go. In general, for vector u, it would have xi plus yj, and the components are xi and yj. So, all right, let's have a look. Oh, the magnitude, the size, the length of vector. So this vector here, AB, we wanted to know how long that would be, and we could draw it out like this and use Pythagoras. A squared plus b squared equals c squared. And so we could do that, and of course we know they're 3 and 4. So we could do that. And so the size or the length of vector u is written as these two signs here, magnitude, absolute value. What it means is we just want to know how big it is. It doesn't matter whether it's positive or negative, we just need to know how big. And that's what these two vertical lines either side mean. And so it's calculated by the magnitude of u is the square root of x squared plus y squared. And that, of course, is derived from our old friend Pythagoras. Okay, so there's a bit of talking going on there. All right, so the next bit that we are looking at here is A and B be the points on the Cartesian plane. So that OA is 2i plus j, and OB is I plus 3j. So the way I will go about doing this is I'll do a sketch, and I like to do sketches. So here's a sketch, y and x. Get rid of that. All right, 2i. So of course O is here. O is there. 2i, so we're going 2 across, and j. So 2 across, 1 up. And so this is A, so that's OA. And OB is I and minus 3. Down here, I'll put the coordinates in of each of those points. And so what we are after is the magnitude of AB. So first of all, we need to find AB. And because these are position vectors, we go A straight to B. We go A to O to B. A to O and then to B. So if you like, it's OB minus OA. And so I minus 3j minus 2i plus j. Alright, so we got minus I, minus 3 minus another is minus 4j. And so the magnitude of AB then would be the square root of how many lots of I? You've got -1, -1 squared, and you got minus 4 lots of j, so minus 4 squared. So what have we got? We've got the square root of -1 squared is 116, and so our final answer here will be square root 17. That's for the magnitude of AB, vector AB. All right. So let's have a look what else. Unit vectors. All right, so I already kind of touched on this unit vectors. What are they? Well, unit vectors, as it says there, are a vector of length 1 unit. Now, I already mentioned up the top there that I and j are unit vectors, but we can have any vector being a unit vector. So up here on this example, what I've got here, I did draw vector AB, which I didn't, but if I did, so vector AB goes there like that. So that's vector AB. Now we've just found out how long it is, and I can have a unit vector pointing in that particular direction if I wanted to. And I need to bring in this magnitude, this length in it, because at the moment it's square root 17, which is 4 and a bit, but unit vectors are length 1. So I would need to make that unit vector, turn it into a unit vector. I have to make it length 1, and I can simply do that by dividing by this magnitude. All right, so having waffled on with all that, a unit vector is a vector of length 1. So the unit direction vector in the direction of vector A is written A with the hat. So A hat, that's a unit vector. Any vector you see with a hat is a unit vector. We know that's length 1. And so A hat, to get A hat, you would have 1 over the magnitude of A times vector A, or if you like, A hat is vector A over its magnitude. So that one up there that I had before, vector AB was minus I minus 4j, and the magnitude of vector AB was root 17. So unit vector AB would be minus I minus 4j on root 17. All right. Now I have got an example of working one out. All right. So let's have a look. Here's one here. Let me change my colour back to blue. All right, so vector A is 3i plus 4j. Find the magnitude of A and then A hat. So the unit vector in the direction of A. All right, so the magnitude of vector A is the square root of the I component squared plus the j component squared, square root 9 plus 16, which is 25, which is 5. So that means that vector A hat, we can write it in two ways. One of them we can write 3i plus 4j all over 5, or you can write it as 1/5 of 3i plus 4j. All right, doesn't really matter which way you write it. though sometimes this second form here is, we can use that more easily in some other calculations that we'll get to in next lessons or the lesson after, where we can use that. All right, so ij components. So the I is in the x direction, the j is in the y direction, and then we've got unit vectors. All right, and so unit vector pointing in that direction, you take that direct vector and divide it by its magnitude, and there it goes. All right, so we've got some practice questions now. So if you've got any questions, anything you need clarifying with that, make sure you seek help. And as always, have fun.